Hi, at Principal AI, we build state of art AI technologies and assist other companies solve their AI problems. In this series of videos, we are going to do some system design problems to assist engineers improve their system design skills and crack our software interviews. If you like this video, I would request you to subscribe to our channel. In this particular video, we are going to design a feature flag system. Now, in any software company with a feature flag system is essential. It allows developers to roll out features very safely to users and sometimes to subset of users. A stable system in production should not be modified without involving feature flags. Whenever you roll out a new feature, it can break the existing functionality and give users a bad experience. But if you roll it out guarded by feature flags, you can selectively enable it for specific test users or a specific traffic and monitor the performance and make sure that it does not impact your entire traffic. This is generally considered a very good practice, and companies will have their own processes and guidelines around it. In this video, we will design a feature flag system. Here is a problem statement. We will approach this system design problem one step at a time. The first is always to read the problem statement carefully. We notice that we are designing this system for a startup. This is an important detail. We are not designing this for a large company like Amazon or Google. We are then provided an API called isSet. This takes two arguments, a flag name and a properties object. Remember that whenever you are provided such details, it is for an important reason, and you should always focus on exactly that those details entail and go deep into those details. For example, you can ask interviewer to give an example of the API usage. Now, assuming that you're already familiar with how feature flags generally work, this is pretty straightforward to understand. But as we solve this problem, we need to make assumptions, and we need to state them very clearly and make sure that we have buy-in from the interviewer. We'll design everything that's needed to make the above API work. Now, even if you know the problem, even if you have done this before as an exercise, do not rush into answering the question immediately. Instead, take a pause and try to ask questions. Sometimes it helps to give a structure to your question, as you can ask what are the functional requirements and what are non-functional requirements. Now, in this particular case, we notice the word startup. So we are going to ask more questions about that. Can you tell me more about a company and their systems? What kind of company is it? Is it an e-commerce company? Is it a fintech company? Right? And all these kind of answers determine the kind of system we need to build, the kind of traffic we need to expect, and so on. So, in a normal news website, if a page doesn't load fast enough, something gets loaded when it was not supposed to. It doesn't cause much harm. But in a fintech company, it could mean lost revenue. These are something that we think we need to keep in mind. Now, is this a web application, or Android application, or iOS application? And the answer here is that it's all three of those, and they have around 10 million monthly active users, which might translate to, say, a million daily active users. And the product is a consumer app with some payment related flows, but it's more like a social network. So the interviewer is being vague here, and which is a hint for you that it is probably doesn't matter very much. Now, do we need to support just web clients or also the apps? And the interviewer is very clear that we need to support all three, and our design needs to have something for all three of these cases. Now we come to the non-functional requirements. How many flags do we need to support? So in any system design question, you need to ask questions like this. How many users does it have? If you are building for, say, a reservation system, a booking system, how many reservations will be there? Does this appear to be read heavy system or write heavy system? Now, feature flags are often modified very, very few times, but they are read extremely often. So the interviewer says there will be around 1,000 active flags, which is not a lot. So this is ready heavy system. Now, feature flags are often modified very, very few times, but they are read extremely often. So the interviewer says there will be around 1,000 active flags, which is not a lot. So 1000 flags can technically fit in a phone memory as well. Now, do we get to own and build our own SDKs for servers and clients, or are we going to use something else? And the answer here is yes. So that kind of gives us freedom to define the API and its structure. Now, even though you have answered a few questions, there is no need to rush into answering this question. We'll just take a pause and wonder if you have got everything. Now, so far, we have asked a few questions that have given us a good idea, so that there is a concept of client SDKs. We need to support three types of clients, or we can even say to mobile and web, and server side flags as well. Roughly, whenever there is a requirement, we can think of a microservice that manages that particular feature. So in this case, it's a flag. So that will be a flag management service. We have we have a very good understanding of traffic patterns here because there are 1000 flags, maybe a million daily active users, 10 million monthly active users, not a lot of traffic, but we still need to keep scalability in mind. What are some of the non-functional requirements? How often do these flags change? We assume once a week, every flag changes once a week. How are flags changed? I think this is a very important question, and the interviewer says that, there is a UI that will be used by developers to change the flags. Then how soon this change be propagated? And the interviewer says 30 seconds, which is a pretty reasonably large window. And what about the security primitives? The assumption here is that we do not have to worry about flag propagation. We now have a good understanding of high level design. We should take a pause and ask interviewers if our high level design makes sense and if we have missed anything. This buy in is very important because if you get your high level design wrong as you go in details, you know, it will either reach into an area where the interviewer doesn't know where it's going or the interviewer didn't expect you to do something, and when you reach that territory, the chances are that either of you will be confused. Always come up with quick high level design and then discuss it in detail. Always mention all the components clearly. Tell the interviewer purpose of each of them and what possible alternatives can be considered. And if we designed it in this particular way, what were the other options that we had and what were the pros and cons of those options? And why did you make this particular choice? And very likely, if the interviewer doesn't expect you to do something, this is where they'll stop you and they'll say, no, no, this particular con is more important than the pros. So maybe you should consider other options and so on. So you can then change your high level design based on how the interviewer wants it to go. Now, how do you actually come up with a high level design? Now, there is no good answer to that, and there is no quick method to that. You need to have sufficient experience and you need to have the talent to come up with this. So in this particular high level design, we have done this quick chart of different components, and we'll talk with the interviewer to get some buy-in. Now we know that there are mobile apps, so we have created a client-side SDK here, which will be used by our Android and iOS apps. Right? Then the client-side SDK talks to a public API gateway, which could be a load balancer or something like that. It's fine. It's also responsible for doing authorization and authentication, right? And the public API gateway will serve as a gateway to our actual microservice, which we call feature service. Now, later we might split this feature service into multiple services, but right now, in this high level design, we create a single component. Then there is an internal UI to create new flags and modify those flags, and there is server side SDK, which will be used by other server side microservices. This SDK is responsible for reading flags. Now, the feature service is responsible for maintaining the state of flags. And we have a choice of database. So whenever we talk about state, we need to ask, hey, how are we going to store this? And the choices typically are but in memory, a SQL like data model. Sometimes a NoSQL database, sometimes a time series database that can store time series data. Sometimes it can just be a version control system like Git. P2 here, a NoSQL database seems to make a lot of sense. So in this case, we said that we'll create a NoSQL because remember, when we looked at the API, it had this properties object, right? And a flag name And the properties object could be very open ended and can be literally anything, right? So we don't want to keep up with our schema tied to that object. Um, and that is why we have preferred a NoSQL database. Now, did you see what I am doing here? I am actually telling the interviewer why I made a choice of NoSQL database here over a relational database like MySQL. Also, whenever you talk of database, you need to talk about scaling. Now, in any system which is write heavy, it is slightly harder because the writes can happen across multiple data sets. So, centers across the geographic regions, and they have to be consistent, and there should not be any race conditions, etc., etc., and the writes have to be fast as well. But we are lucky because this is a read heavy system, so we can technically have one replica, which is write only, so all the write queries get routed through the feature service to that specific database, and there could be multiple, eventually consistent read replicas of this database. Now, if you are using any cloud service such as Amazon, Google, Google Cloud, etc., they have this sort of NoSQL databases with replication, and you don't have to worry about them. And we have also showed two calls here, post and get. Now, this is only indicative that the SDKs are supposed to read the flag state, and the internal UI is supposed to write flag states. And we are not going to go into the details of this REST queries themselves. So this is a high level design, and you propose this design to the interviewer and see what they think. Have you missed anything here, right? So one of the obvious questions that comes to mind here is, okay, is the server's SDK going to read all the flags all the time, like 1,000 flags in every single call? How often will that happen? And why does it need to happen that often? Right? Can we do something better? Alternatively, is NoSQL database really required? Or can we just use something in memory like Redis, right? Because every time the server SDK reads it, do we really want to go and fetch that data from NoSQL, making it somewhat slower? When will the server actually read this particular flag? Whenever it's when, and remember, like, we are supposed to design this system from the API that was given to us, isset. So every time isset method is called, are we going to make this REST call? So these are some of the questions that the interviewer might ask. But you can stop them and say, hey, we'll go into the details next. But in terms of component wise, does this look okay? Now, when it comes to flags, there's one detail we have missed here. When the developer creates a flag, developer might create a flag as my feature and switch it on for, say, all the users with user ID. That is an odd number, let's say. That's a simple flag that developer creates, but the value of that flag needs to be computed in runtime. That's something we'll address later, but it's something to keep in mind. So in the next part, we will translate this high-level design into more low-level design. So if you like this video and if you have any questions, more questions, or even criticism, please make sure you drop some comments. They are very important for us and we will respond to them. If you want us to address a specific system design question, do let us know in the comments and we'll try to provide a solution through our videos whenever we get a chance. Please subscribe to our channel and also like this video. Thank you.